One of the things that's holding back the current agent architectures and chatbot architectures of generative AI companies isn't what you're being told in newspapers, articles, where we're hearing things like, well, we just need to pass this next test, or right around the corner, don't you worry, we're going to get a AGI based solution. And this AGI solution, or artificial general intelligence, or wide AI, is going to solve all these problems. But let's actually decompose the system and assume for a second that all of these technologies are narrow AI, or even you could classify this as just simple machine learning. K means clustering. So they're good at doing patterns or linear regression. They're able to predict a data point. And if you look at each of these different components of machine learning, like classic machine learning problems, unsupervised machine learning, supervised machine learning, reinforcement learning, these all are able to solve a very narrow problem. And what's happening is the combination of all of these narrow machine learning or narrow AI solutions together are being put inside of a deceptive user interface that's designed to appear to be competent. And this is really similar to what we've seen in the past with other deceptive technologies like Mad Libs, or these kind of chatbots that appear they're intelligent. But what's really happening is that none of this has any form of intelligence, but they are combined together to appear to be intelligent. So here's where we really get into a problem, which is that there is value to machine learning. There is value to linear regression. There is value to these types of technologies. But if you think of them as a narrow system, or a narrow machine learning problem, or a narrow AI problem, and so really in many ways, our biggest problem is the user interface, is that we have these deceptive chatbots and that tell you things in a way that are overconfident, or make you think that they have competence in a certain thing, where if you treat them just through an API, for example, you start to get much better determinism. When you use things through an API, you get a lot better use cases when you use it from an API, because their deceptive chatbot interface or their deceptive agent-based interface, it has been removed. So in many ways, the biggest problem to being productive with the current tool sets is that you have to get around the deceptive user interface problem. And you could define this as the fake intelligence problem that you get from combining multiple narrow AI solutions. And this is really an inflection point. If you believe that by putting these narrow pieces together, we're going to somehow cobble together a form of intelligence, then unfortunately you're a magical thinker. And who is saying this? Well, if you're talking about people that are selling software, the salespeople are saying things that are untrue because they want to get a sale. Or if you look at maybe a chip vendor saying, hey, we don't need coding jobs anymore, they're saying these things because they want people to buy chips. But if we know that there's no form of intelligence, instead that each individual component is useful but has no form of intelligence, in many ways you're going to not be able to get the best outcome if you are deceived about what the true capabilities of these components. So one of the ways to decompose this type of deceptive system is to look at each of the steps that are involved, or the capabilities that are involved, and demystify them. So for example, if we look at a chatbot versus a traditional system component, text generation, well, this is the transformer large language model, and this is the implementation. But you could do something kind of similar if you were able to use non-machine learning. You could have a rules-based template, and maybe you use like Mad Libs or something like that. And this could be pretty helpful, right? But the problem is there's a high deception risk, and also you have a harm potential problem. If we look at the next component of a chatbot, we have context management. And this is where we have the attention mechanism, where you're able to say, look, here's all my code, please complete this section. That is really useful, but you could also do that in another way. You could store, for example, session cookies or a database, And you could see here that the harm potential with that is probably a lot lower because we actually have curated that data. You also have intent recognition. So in that case, you could look at a fine-tuned classifier as the component that's being used, but you could do the same thing with a core component that is a regular expression. If we look at the persona, right, these are like, oh, look at this, I'm using a persona. Well, this is just a conditioning that's being done in the large language model, but you could also hard code different styles, right? So you don't have to use that kind of machine learning technology. If you look at the knowledge base, this is just parameter encoded information, but you could do the same thing with a lookup table, right? You could have like frequently asked questions. So once you start to dive into some of these core components, you start to realize that there is always an analogous non-machine learning solution. So if we look at tool integration, oh look, we can call frameworks, but you could also do that with a command line tool. If you look at safety guardrails, well, we could do that with a block list. If we look at retrieval, the vector embeddings, well, we could do a Boolean search. Look at planning, this is the chain of thought. Well, you could do the same thing with the decision tree. Everything that you do in machine learning in these large language models has the equivalent that can be pulled out. And I think in many cases, some companies that are looking for making things deterministic might want to look at how to decompose the deceptive components and replace them with deterministic components. And likewise, the agent specific components have been around for years and years and years. In fact, the build system is if really similar to that. So if we look at action selection, right? Well, that's just if then rules. And we can see that could be done before there was machine learning. In fact, the build systems then say, if this job passes, then run this other job. Likewise, reflection, if you're, hey, look, there's a bug, etc. Sure, those kinds of things can occur, but you could also do a validation script that could have the same kind of result, right? So if you run a machine learning model and it fails as a result of some bug it finds, yes, it could look at the output and then go and do a corrective action. But you could also do the same thing with a validation script. You could attempt to do something, but then there's try except logic that goes through and it says, well, oh, we got an exception. Let's go ahead and try this other thing. So is it magic that's happening here? Is it intelligence, or is there in fact a different equivalent? Likewise with memory management, you instead of doing vector databases, you could do CRUD or goal tracking with reward modeling. You could also do state machines. And then finally, if you look at these kind of multi-step reasoning, and all that means is you're taking the result of one machine learning operation or large language model operation and feeding it into another. You could do the same thing with a procedural algorithm, right? You could say, look, if you could have a case statement, if this and this and this happens, then go ahead and do this, right? You're just branching through. So really, to summarize here, one of the ways that you could really dive into making systems less magical and less deceptive, in fact, using the value of what these large language models really are best at, which is finding, patterns or giving you predictions based on patterns. One of the ways to do that is to decompose the deceptive components and replace them with deterministic components. So in a nutshell, how would you do this? Well, I think one of the ways you could do this is to focus on reducing the amount of things you ask these systems to do. So for example, if you open up an agent like Claude Code and you say, I want you to create a makefile command that does this following thing, it reads in your README file, it reads in the context of your project, and it gives you a prediction of what likely your makefile command should be. That's a great way to use a machine learning model. You exit. Instead of you then going through and asking it open-ended questions and all kinds of things where it has no form of intelligence, so why are you asking it something that it's not going to be bad at? If instead you're the person who is asking very narrow things that the machine learning models are good at doing, like predicting what the syntax would be of a command or predicting what the next function should be, that I think is the way to use these agents. So what it means as well is that you have to get out of the magical thinking mindset and get more into the critical thinking mindset, where you try to have a very small and reduced set of things you ask an agent to do, or a chatbot to do, or an API call that you do. And that's really the way to get the most value. And it's not even close to think that these types of systems will replace software engineers, because it's non sequitur. We know that the only things they can do are very narrow, specific components that are all chained together to appear to be more valuable than they actually are.